So the next proof technique that we're going to talk about, the next tool in your proof toolkit, as it were, is a proof by contrapositive. And this is contained in the Book of Proof, section 5.1. And this is one of my favorite proof techniques, because what it relies upon is a fact that we've already seen when discussing logic. In fact, this relies on the following. We have already seen that P implies Q is logically equivalent to not Q implies not P. So let me go ahead and recall what a direct proof was and show you how that differs from a proof by contrapositive. So in a direct proof, of P implies Q right here, the way that this proceeded was we assumed P right here. We had an argument that then allowed us to conclude that therefore Q. So how does this differ from a proof by contrapositive? So a proof by contrapositive of P implies Q proceeds as follows. You first off say, okay, I know that P implies Q is logically equivalent to not Q implies not P. So what I'm going to do here is a little bit nuanced. I am going to take the direct proof method and apply it instead to this conditional statement right here. If not Q, then not P. So if I want to apply the direct proof method to the contrapositive, what that means is I have to assume the hypothesis right here. So I assume not Q. And then I make an argument that allows me to conclude, therefore not P. And the whole reason why a proof by contrapositive works is the exact same reason why a direct proof works as well. Because if we look at a truth table for both P implies Q and not Q implies not P, we have the following. So filling out this truth table right here, we know that the original statement and its contrapositive are logically equivalent, so they have the same truth table. And let's go ahead and see how this works. So we are assuming not Q. So we are basically assuming that Q is false. So if we assume Q is false, why does that work? Well, because if Q is true, then we already know that the thing that we're trying to show is automatically true as well. So we don't have to consider this row, and we don't have to consider this row right here. We don't have to consider those because what we're trying to show is already automatically true. So the only cases that we'd have to show for this particular proof by contrapositive is when this Q right here is false, right? Not Q. So what we're trying to do is exclude this case and instead show this case right here. And Remember excluding this case right here because we want the thing that we're trying to prove to be true and not false. So we want to exclude that case and we want to show this. Well, what involves showing this? Well, we already know not Q, so Q is false. So what we would have to conclude is that P is also false. P being false right here, we would have to conclude not P, that P is false. So we want to show this last row right here and exclude that second row. However you want to think about this, a proof by contrapositive, either by using a truth table or just knowing that it's a direct proof of the contrapositive, which is logically equivalent to the original statement, both of those are fine to think about a proof by contrapositive. And don't worry, we will look at a lot of examples of these.